This is the machine that we're going to be working on today. As you can see, it's an issue 6A board and it has a Spectrum lower RAM replacement PCB. The owner tells me that he fitted the lower RAM board and got some problems while trying to run diagnostics, really crazy sporadic intermittent behaviour, and tried to remove the lower RAM board, and I know this pain just as well as anyone. Those things are really hard to get out. Just make a path for the cat. Yeah, I know as well as anyone, those things are really hard to remove once you've soldered them in, so he sent it to me to get the thing out and to try and figure out what was going wrong. Let's have a tour of the board, starting with the upper RAM chips. The reason I'm showing you this is because look at the dirt, it needs a good clean. I'm sure that's not causing any problems, but I'm going to give it a once over with a toothbrush. Oof, not very good. Well, alcoholic spirit and a toothbrush will sort it out. The ULA is a 6C111E and I think it's a 6th edition one, 6th generation. Looking on Byte Delight's ULA gallery, I can see a couple more examples there from week 46 of 84, so they must have made a batch here where they didn't print the suffix. Down at the bottom we have the lower RAM replacement board from Retroleum. It just uses a static SRAMM chip, some flip-flops and another bit of logic to handle the addressing. They work a treat, but as I said, be warned, they are hard to remove if you solder them direct to the board. They're also a little tricky to get in because the pins are so rigid and if your sockets aren't absolutely perfectly aligned. Speaking of PCBs, did you know PCBWay, this video sponsor, are running their 11th year anniversary celebrations? There's a couple of weeks left of it, go check it out, there's lots of coupons and offers to be had. I use PCBWay for all sorts, from prototyping PCBs to 3D printing. It's a fantastic service and very highly recommended. Go see what they can do for you. We have a composite video mod in the form of a transistor mod, and I'm just pointing at this because I wanted to say I'm going to have to be careful to make sure this doesn't short out to the casing, but later on this leg is just going to fall off. I guess it's quite weak and I'm going to replace it with a capacitor mod, which I'm familiar with. The SRAM boards don't use all of the sockets of the lower RAM, obviously. Most of the pins are shared between all of the lower RAM chips. We just need the 8 data pins of the data bus, the address pins and the voltages and a couple of control signals. So lots of these aren't populated, and the ones that are have been desoldered in an attempt to remove it, and I'm going to continue that attempt in a second. Looking up close under the microscope, link in the description if you want one of these, they're fantastic. We can see that we've lost one pad from one of these joints. No biggie, I'll just get a donor pad and drop it on there. There's no traces coming off it, so that shouldn't be too much of a problem. I'm going to show you here just how stiff these pins are if I try and push them. They don't wobble around like normal socket pins or IC pins, they're really rigid, and that just makes the process of removing them that bit more difficult. Now what might be on our side is they go all the way through to the top here where there's a load of solder, so I reckon a bit of heat on there will be able to remove the pins one by one. One way I could have done this would be to use hot air and cook the whole board and remove it in one go, but that's, I think, going to blow capacitors everywhere and potentially do more harm than good. So what I'm going to do is try to desolder the individual pins and remove them. I'm not sure exactly how this is constructed, so I'm just going to start trying to wick away some solder. I'll get the solder sucker and see if I can remove it. If all else fails, we'll just melt it all the way through and push it from the bottom so it stands proud on the top of the board, the side that we're looking at now. Then it should lift out, hopefully, in theory at least. So I'm just trying to wick away this solder and it's not going very well. It turns out the pins are quite wide where they go through the PCB, occupying the whole joint, and there's just a lot of metal there. It's going to be almost impossible to remove the solder which is holding it to the PCB and to the joint. Yep, that thing's not budging at all. I did try in vain to reflow the joint from the bottom and remove the solder. Maybe that would be enough to free it from the top, but no luck. We're going to have to melt the whole thing and push it up from the bottom. This worked surprisingly well. All I did was stand the board upright in a vise, as I like to do, heat the joint from the top. I did have to apply a lot of heat to get everything molten, give it a waggle around with, well, I used a screwdriver on the left hand side, and by pushing on it, it came out the top, and it was pretty much free of the joint. But to be sure, before I try to lift the board, I wanted to remove the pins completely, So I could now grab them with the tweezers, heat them on the joint, and they would be fairly easily removed. A little bit awkward, but I did get there in the end and got all of the pins, nearly all of the pins out. A few of them were already free, so most of them did have to be removed like this. With most of the pins out, I wanted to clear all the joints because the board, at least on the left hand side, was flush to the Spectrum PCB, and I didn't want any solder to be bridging and possibly pulling up tracks when I try to remove it. So time to go around and clear all of these joints. Which was partially successful. You can see it's free on the right hand side, but where it's flush to the board there must be some solder connections holding it down. And you can kind of see where the problem is with the microscope looking between this tiny little gap, and after a lot of fiddling around I realised the best thing to do at this point was turn to the hot air. Really pleased with this little hot air workstation. Again, I'll put a link down in the description. If you follow the link tree you'll be able to see which one I'm using. And I just took the nozzle off and washed the whole thing in hot air and it lifted out really nicely. Okay, now we can inspect all of these traces and make sure everything is tickety-boo. I know there are some patches already done, but I'm just going to redo those so I've seen the process from start to finish. I want to clean everything up here so we don't miss anything, starting by clearing any excess solder out of any of these joints, and then taking a look for any broken traces after a quick once over with a toothbrush and some isopropyl alcohol. And taking a look under the scope, we can start to inspect the damage. First of all, we have a lifted pad here with a broken trace either side. I'm really not sure if this was already there or was damaged during the fitting or the removal of the SRAMM board, but either way we're going to need to trim back those traces because they're not long enough to patch up, and put a patch wire in, well, 2 patch wires. I found the remnants of a patch here on the top side with a bit of enamelled wire, so I'm going to remove that and redo it myself. Just heating the trace there. It looks like a very small break in the trace. Maybe we'll be able to patch it without a wire. Let's have a look after it's a bit more cleaned up. And over here there's another patch wire going between a joint and a via. Again, it's a very small break in the trace and I might be able to just bridge that with some solder. So let's remove the old patch and we'll clean up and have a closer look. Alright, so making sure we don't miss anything, let's recap. There's a patch to make here in the bottom left. There's a tiny break here in the trace that I would have missed if there wasn't already a patch there. Wait, let's see. You can see it moving there. So we're just going to patch that with a blob of solder and I think that should be fine. So adding a little bit of flux, putting some solder on the tip of the iron and dragging it across. Oops, we've filled the joint there left of it, but that's fine. It looks like the joint's been made pretty well. Quick test, giving it a poke. Obviously we'll do a continuity test as well, but I'm happy with that. Obviously we have this major bit of damage around this joint. I'm going to trim the left hand trace here. I did have ideas of making the right hand connection just with the leg of the socket, but in the end I ended up trimming the trace back as well, just to be safe. And we have another tiny little microscopic break in the trace here, so we'll patch that with solder as well. So I just cleaned the area a bit, put some flux on, put some solder on the tip of the iron and dragged it across, and it made the connection. And quick check with the meter and we did have continuity, lovely. Just wanted to double check the first break that we found on the bottom left of the board. It's a bit dirty there, so I'm just scraping away a little bit, trying to see how big this break is, and it's looking like it's a bit too big to patch with the solder blob, so I'm going to put a patch wire in on the underside of the board. We can start putting some sockets in now, but I'm not going to solder them in completely because I want the patch wires in place before we do that, so I'm just going to tack in all 8 sockets. Alright, and fast forwarding, there's our sockets in. They're almost right, a little bit wonky because these things are really wide, they really kind of bully each other for space. But now we can start making some patches. We did have a missing pad on the underside of the board with no traces coming off it, so what I'm going to do is put a donor pad in from a knackered old board which is beyond help, and then just solder it on there. I think this does make for a better finish. It doesn't really add anything in terms of functionality, but I feel like this is good practice. And we can put our first patch wire in now. Going to use this lovely green camouflage wire, and I'm just measuring up here to cut the patch to size, being super careful to link the right joints. And now we just make the connection by dropping our staple shaped piece of wire into the joints and soldering it up, being really careful not to apply too much heat because you can see the coating of the wire receding there. We don't want too much bare metal exposed. Now I'm going to solder up the rest of these joints. In hindsight, I should have soldered all the joints except the ones I needed to patch first, because I'm just being a little bit careful with not applying any more heat than we need to that patch wire, which will compromise its coating. In fact, let's just bend that out of the way there. Lovely. And we can continue soldering up until we get to our next joint that needed a patch. And if you recall, we needed 2 patches around one joint, so let's get one half in place first. There we go. And before soldering up the other half, we need to put the other patch wire in, and that needs to go to this via here, which I found by probing around for continuity. So I'm scraping away the solder mask around the via so we can make a good connection, and then we can place our second part of this patch. And again, being careful not to apply heat for too long so we don't melt too much of our patch wire's coating, we can finish the job. Alright, all done, lovely. So we can do some initial tests now. I'm going to check resistances of the 3 voltage supplies that lower RAM receive to ground, looking for anything which is too low. These are going to be much higher than we're used to seeing because there's no lower RAM chips installed, but they all seem to check out okay. 0.5 ohms was ground to ground, by the way. Current draw seems reasonable with no lower RAM in, 400 milliamps. And a quick check of voltages. We're getting -5, that's looking good. What about +5? I expect it's fine because we have -5, and it is. And what about +12? 12.15, not bad. Okay, it's Jim from the future here. Did you see it? I just glossed over something which could have given away where the major fault is with the Spectrum, which is about to melt a few of my lower RAM chip stock. If you spotted it, well done, let me know in the comments. In fact, I'm just going to tell you, the 12 volt reading was moving a tiny little bit, and I should have put a scope on it where I would have seen that it was spiking to 16 volts. So yeah, I'm going to reveal the problem now and we can all laugh at me while I continue to melt RAM chips trying to figure out what the problem was, feeling confident that it wasn't a problem with the voltages. Okay, over to Jim from the past. The SRAMM board is in bits and I am going to try and reassemble it soon, but I just want to try with known good 4116 RAM chips just so I can take the unknown of the SRAMM board out of the equation and get this board up and running. So let's see what current we're drawing. And immediately went to constant current, so it totally maxed out and started limiting the currents. So what am I doing here? I'm just trying to increase what's allowed from the power supply a little bit because these are new chips, so how could it possibly be limiting the current? And oh, it's done it again. Okay, we better have a quick check of our resistances again. Resistance from the 3 voltage supplies to ground. And on the 12 volt pin to ground we're getting 11.9 ohms, which is dreadful. One of these chips is melted internally. How could that have possibly happened? Okay, I'll take one out and we'll just measure the resistance. We're not going to plug it in recklessly, are we? Quick measure of the resistance on the 12 volt line to ground with that first chip out, and we're getting 2.3 kilo ohms. That's better. So we should be able to plug it in now and see what sort of current draw we're getting. I guess we had a dud RAM chip. Let's have a quick try, eh? So I've plugged in another RAM chip, which I know is good. I've checked the resistance and we can plug it in and it went straight to limiting current again. And a quick check of the resistance again and we're back down to 12 ohms. At this point I really should have started to wonder what was going on with those voltage supplies. Well, I think I was still falsely confident because I measured them and they all seemed to be fine. So maybe I put in another dud chip and it was on its last legs. Let's remove it and continue testing. This went on and on for quite some time, as you can see, and I didn't get any closer to figuring out what was going wrong until I got the oscilloscope out. But that wasn't the next thing I did. I decided to try and run a Diagnostics ROM, so I had a quick clean around of the board, cleaned the edge connector, plugged in the dandonator, connected up my composite video, and it wouldn't run. and I thought I'd be able to get something out of it with no lower RAM in, and well, it does turn out that Dandinator is not a great choice if you don't have lower RAM in, so lesson learned there. But it wouldn't run, it would not give up control to the device on the edge connector. So I thought, oh, maybe there's a line of inquiry, let's remove the ROM chip because that might be faulty here if it's not allowing the Dandinator to run. So a quick whiz around with a solder sucker and a quick check of continuity for all of the joints going to the ROM chip. I was able to plug in a Dandinator and it should definitely run the Diagnostics now. And it kinda did, and it looked really weird, and I think it tried to tell me that all of the data lines had failed, which makes sense because there was no lower RAM installed. At this point I started to get onto the right scent, and I thought it must be something with the power. Don't know why I didn't put a scope on the power supplies. Instead, I replaced the modulator and TR4 and TR5. Sorry Peter, I did use a ZTX751. Having changed those transistors and the modulator, I finally put a scope on each of the voltage supplies to lower RAM, and I saw something very interesting, which you might already have realised or been told. Look at this 12 volt supply, oh dear. I haven't seen this before. I've seen it stuck at 20 volts, but I've not seen it rubber banding twanging around like this. It's around about 12 volts, but it's spiking according to the oscilloscope to about 16 volts as you can see. And that seems to be what is absolutely frying all of my RAM chips. They are max 16 volts. Oh dear. So what we're going to do, we're going to replace the two 100 microfarad capacitors at the bottom center of the board, because these are totally integral to the generation of the 12 volt power supply, and I know that replacing them is hopefully going to sort this out, so let's try it out. Okay, drum roll please for possibly the last use of this handheld oscilloscope you'll see on the channel because I'm upgrading, and it's flat, 11.8 volts. Alright, I'm going to put the RAM chips back in now, and I'm going to be constantly measuring the resistance of 12 volt supply to ground, making sure I don't put any in that I've already melted. And I should be able to run a full diagnostic program now off the Dandinator. Yeah, it's working, so let's launch into a diagnostic run. Alright, it's looking a bit funky, but it's looking a bit more familiar at least, and the result is a RAM failure, bit 4, so we'll replace that. And I've actually switched over to another external diagnostic card now because I was having some trouble with the Dandinator, and I'm running the Retrolium diagnostic ROM, and this time it's going to tell me that bit 7 is the problem. So maybe I've used a couple of half fried RAM chips. That's okay, we'll replace them, that's why we're doing the tests. And this time it ran from start to finish with absolutely no problems and a pretty good picture. So I think it's safe to say that we've fixed this board, at least using 4116 chips. Now I need to put the ROM chip back in, but I'm out of sockets of that size. I've ordered some, but if I can just test it, I can solder it back to the board. So I've popped it into this old issue 2, which I have in the pile, and it seems to work, so I'll solder it back in. With that done, all I need to do is redo the composite video mod because one of the legs of the transistor just fell off. Like, it was really weak, so I'll just put a capacitor in its place. And a quick check that the ROM chip's working and the comp mod is working, and everything looks good to me. So it's time to go to surgery on this SRAMM board, see if we can recover it. Hopefully we can, hopefully it's not sustained any damage. Starting out by simply clearing the joints, ready to reinsert the pins which will slot into our sockets, hopefully. So this was fairly painful, but I figured it out in the end, so I dropped the pin into the joint, heated it quite a lot, and poked it around with a screwdriver until it slid into place. Once it was in there, it was pretty rigid. And miraculously I hadn't lost any of the pins, so I was able to replace them all, which is fantastic. Then it would just be a case of cleaning up and trying to get it to fit into our sockets. I did get the board to go in. It wasn't the neatest fit ever, pretty tight. Those pins really are very rigid and your sockets need to be aligned really well. So when it was sitting in there not fully fitted, it did boot okay, and then I seated it properly into the sockets, a little bit of force, and it stopped working. I guess it had finally had enough of being overworked like this and sustained some damage. Now, shame on me, I couldn't figure it out very quickly, so I put the RAM chips back in and started doing my final testing. I was just about ready to wrap it all up and send it back, but my conscience got the better of me and I decided to put a bit more time into trying to figure out what had broken on the SRAM board when I finally placed it into the sockets. So re-enter the handheld oscilloscope, and probing around the SRAM chip after reading the datasheet and reverse engineering how this board works a little bit, I found that one of the address lines going to the SRAM chip was pathetic. It wasn't reaching 5 volts at all. It did resemble a square wave, but the amplitude was way off. So I traced that back to one of the pins which I'd inserted and reflowed it. I reflowed them all, to be honest, because I guess one of them must have just cracked when I placed it into the board. So put a lot more heat in there, reflowed everything nicely, plugged in the dandinator, crossed my fingers and gave it a try. Here we go. And it worked. Lovely. We've rescued the SRAM board as well as this specky. At that point I just redid all the final tests, packed it up and sent it back to the customer. Bit of a chewy one that, but I learned a lot. The main thing being to check your voltages with an oscilloscope if you have that luxury. Oh, and how the SRAM board works, which was interesting too. Anyway, thanks for watching. I've got 3 more repairs on the pile and they're going to produce some interesting videos, so stay tuned, lots more to come.